It's on cloud. Okay, perfect. Is it good? Okay, thank you so much, Bill, for accepting our invitation. It's our pleasure to have you in our webinar. And it's the first webinar in our department. We are so excited about that. And we have started a series of webinars. And the stage is yours. Thank you so much. I appreciate it if you could, introduce yourself for a couple of minutes before starting your presentation. Thank you.
Sure, no problem. Yeah, I appreciate the interest and for the chance to speak with you. My name is Bill Nassauer. I work for Komatsu's. I'm based in Tucson, Arizona, but I'm part of Komatsu's mining technology solutions team. So basically, our organization is responsible for making several technology products specifically for the mining sector, including fleet management systems known as dispatch throughout the industry, machine guidance systems, and autonomy. So I'm going to talk specifically about autonomy because I'm also kind of within a subgroup of mining technology solutions. We have autonomous systems. My role is I'm the manager of product strategy for autonomous systems, which means that basically I'm in charge of product management. We've got 4 product managers who work on that are basically running the show in terms of planning, development, and listening to our customers and understanding their needs and priorities and making sure that those are reflected in our development process and timetables, and also then communicating back, of course, what we're doing, up, down to them as well. So basically, yep, that's me. I'm sort of the longer term planning guy, and we're always looking at what's going on from a technology standpoint in the industry. And our flagship product is the haulage system called Front Runner, but we also work in some other areas. But I'll talk mainly about the AHS system today because that's the one that's been commercialized for 16 years now and well known in the industry. And this is really what what's our product today. So that's basically me. And I'll just kind of dive into this, and unless there was anything else you wanted to say.
Nope, I think that's
okay.
perfect.
All right, so yeah, Front Runner, this presentation is sort of just an overview of what it is and what it does, and I'll also talk a little bit about where we're going in the future, but to start with, AHS is, like I said, it's been around a while. It's a system that's designed for really focused on safety above all, but also the goal of the system is to improve safety for all of the folks who are within the mining, in the mine and in the running that system. Also to improve productivity and reliability of the equipment, essentially all of those things. And so, yeah, this is just kind of an explanation of what we're trying to achieve. Around the clock, you'll probably see that theme mentioned several times. It's one of the things with an AHS system is that the truck fleet, with the exception of fueling and maintenance, it never stops. So there's no shift change. The trucks don't have to stop necessarily for shift change. And so you get a lot more operating time for the equipment, and there's increased productivity associated with that. It also, in terms of cost, not only for the increased productivity, but the way that the trucks are driven is exactly according to their specifications. So the trucks are not abused, the equipment runs to spec, and so we also see our customers have increased reliability of the machines themselves, improved tire life, better fuel economy, all of those things. So really, there's a number of factors which kind of are the main benefits of this system. we've been doing this, as I said, for quite some time. It really goes. The story here starts in 2007, but in reality, that's sort of our commercial launch was then. We did a lot of development in the, I would say, decade even leading up to that. I know when I originally started in this industry back in '97, we were just starting the kind of a second phase, you could say, of autonomous development in conjunction with Komatsu. When back then it was modular mining systems working with Komatsu. Yeah, it's been 16 years so far. We started with only one kind of truck, the 830E-1. But later the 980 and the 930 also became were introduced as autonomous models, and basically going forward, anytime we have a new truck model, it's sort of in parallel the autonomous ready version of that also comes out of the factory. So we've definitely evolved over the years, and sort of our near future, we continue to work very closely with the factory on the truck factory, which is Komatsu America in Peoria, Illinois. They are building. We've already got trolley electric trolley assist systems available for certain truck models, but those will start to roll out for all models starting next year, and we'll be supporting that in the autonomous system, along with other enhancements like brake improvements and teleoperation technologies with in conjunction with AHS in use on the loading equipment, things like that. So it's been we have a long history in this area, and Komatsu's been dedicated to making this work for a very long time. We have around it's a little bit more than 630 trucks running autonomously around the world as of this moment. We're proud of that fact. And you can see they're scattered around the world, but our largest number of trucks are in Australia. We've got all these Rio Tinto sites, and BHP has been our more recent additions in Australia. We've also, in the last couple of years, had some explosive growth in South America. Going back a couple of years, the only site we had was Gabriela Mistral in Chile, but as you can see, that's exploded to 7 other sites basically, and we're seeing a lot of growth there. Yeah, over that 16 years, we've had no injuries that that are because of a system-related fault of any kind, and that's something that we intend very strongly to continue as forever. So that's safety has been a huge focus for us. I sort of touched on this before, right? But this is where the main benefits of this system are kind of explained in more detail. So safety, due to you're not putting operators in harm's way, is the biggest thing. Compliance with road rules and safety standards. The trucks, sensor systems and all of that are very reliable, and so this this is something that a lot of mines that really, if they're focused on safety, this is one of their big drivers. The around-the-clock production for productivity, reduced stoppages, tolerance of inclement weather conditions. So the trucks actually perform very well in slippery conditions, for example, and also since you're not putting operators at risk, you're able to run in many situations that you can't in a staffed operation. Cost reduction, and improved tire and brake life, maintenance reductions, and all of our large ultra class trucks are electric drive, and so the uptime and reliability of those are well known, and so that's we're very proud of that. And then on the sustainability side, there's, we make a lot of arguments for this now just due to better use of the equipment itself, but there's a lot of things that are also coming in the short to medium term that are tied closely with the autonomous haulage system, such as battery trucks, which you've probably seen in the news, and we've also experimented with cabless designs and those types of things. All of those are designed to reduce fuel use and to give our customers options in terms of how they power the equipment, whether they want to go battery or even in some cases hydrogen or so we call that power agnostic or power flexible. Those are being built into our equipment kind of going forward. We should start to see that roll out in about another 2 years, I would say. Just to describe, I guess, a little bit of where we sit in this stack of technologies on site. So what I'm talking about principally is FrontRunner, the supervisory system, what we call the supervisory system. That's what runs the autonomy. You could think of this as basically, a truck driver or a fleet of a crew of truck drivers. And what the system is in charge of doing is simply executing the instructions that are coming from at a higher level. And this system utilizes inputs from all of its sensors, from what's known about the weather, and what the folks centrally who are controlling this system are setting up in terms of speed limits and those types of things. Those are constraints that this system operates under. But as I mentioned, the optimization side, the fleet management system actually provides at a higher level what to do. It provides where to go, and it's actually getting more sophisticated as time goes on in terms of telling time, for example, specifying arrival times by which we can adjust speed in order to achieve those, in order to avoid things like traffic contention. In the future, also to manage battery charge, all of those types of factors that go into optimizing what to do with the equipment. That really comes from the fleet management side. And so our product Dispatch works in conjunction with FrontRunner to essentially manage that whole operation. And so, yeah, that's kind of it. And of course, at even the higher level, you've got inputs also from the enterprise level systems that provide the mine plan. Things like where to mine and grade information, and basically all of the planning details that feed into that system. So this whole thing forms an ecosystem. The system has a number of redundant and sort of cooperative safety systems that are built into it. This is something that we've over the years have spent a tremendous amount of time trying to eliminate any possible gaps in this, and it starts with it's these 6 layers basically. Auto interaction basically is a system, you can sort of see what that looks like in this image here, where the trucks are provided essentially ownership of a section of road ahead of them. This subsystem basically manages those and takes into consideration when where the other equipment is, and manages those permissions. Manual interaction is basically how to deal with staffed equipment when they're in the area. So what we call EMVs, which are equipped manual vehicles, and AHTs, of course, being autonomous haul trucks. So when these EMVs are in the area, this subsystem basically can manage their behavior. There's 3 different modes that those EMVs can be in, which affect how autonomous trucks will react to their presence. And so this basically handles that. There's a type of proximity warning system which is built in, which warns those manual vehicles that are driving around when there's potential for a a collision or proximity of a autonomous truck that's coming, right? So this system also provides audible warnings to the to those drivers. What we call CDS, the collision detection system, that's basically a subsystem that manages when there are violations of these auto permissions. So you see an example here where you've got a staffed light vehicle which trespasses onto these auto permissions. This system basically reacts to this and causes the truck to slow down or stop, depending how urgent it is, based on these types of things. And then there's what we call almost a level of last resort on the trucks, the sensors themselves, which are detecting any presence in their path, the obstacle detection system. Any identification of any vehicles or people or even animals that are, in front of the truck will cause the truck to slow and stop. And then the really last resort is what we this stop button. Actually, I need to change the language here because it's no longer called an emergency stop. It's a it's like a motion stop button. It will basically cause all the autonomous trucks in the area to come to a stop. And this is basically for anybody in a, it could be the central controllers who are in the office, or it could be anybody in a manual vehicle. They have the option of pressing this button at any time and stopping the fleet should anything happen, which is unexpected to them or posing risk. So all of these systems are meant to work together to keep the system safe and to make sure that we don't put anybody in harm's way. This is basically just a summary of all the components on the truck which make up this system, and you probably wouldn't be surprised that most of these, I mean, these are sort of on autonomy today. This is sort of the standard set of things. You've got GNSS, which is sort of the backbone of our navigation on site. Wireless systems, which do communication, and we're able to use either like 802.11 Wi-Fi or LTE, so private LTE networks. That's actually the most commonly deployed technologies on site today. Those provide the connectivity with the central system and the rest of the network. The sensors, the obstacle detection sensors in the front of the truck. The mode lights, which are installed on each corner of the front and also in the back, which indicate to anybody observing the truck what state it's in, meaning whether it's running autonomously at the moment, whether it's in a mode which it can be approached or not. So it's quickly clear what's going on with it. And then a cabinet where some of the controllers and other things are installed. There's other sensors too, like things that are on the steering system to measure angles and a lot of other integrated controllers on the truck, which tie into the the drive-by-wire type components. I'll skim over these a bit, but there's a number of roles in the system. As I mentioned, central controllers are the ones who sit in the office and basically control this system. They will run both. Typically, they will run both the dispatch fleet management system and also the front runner related things. These systems obviously interface together and share information. And this person will be in charge of managing the roads, actually making changes to the roads and opening and closing areas and dealing with any kind of exception events which might occur, those types of things. There's a mobile computer, what we call a PTX, which is installed in every light vehicle, which are the support folks who are out and about in the mine and keep the system running. And those folks are charged with also handling exceptions and managing any kind of unexpected events. The loading units, so these are manually operated units, and the person running the machine is in charge of managing their area. They basically can specify where they want the truck to spot from, and they're charged with giving permission for those trucks to enter, and telling them to leave when they're full. They can close their area when they need to do cleanup and that type of thing. They can do either single-sided or double-sided loading. And these are also installed with a high precision GNSS system for to know exactly how the machine is oriented, and each machine has what we call a safety envelope. It's hard to see in this picture, but it's a kind of a rectangular area around it, or a circular area here, which is sort of a keep out area where there's no so that there's no contact possible between them. Then we have a dozer EMV system, and this is designed to help manage dumps in particular. That user can specify individual dump points where they want loads to be deposited from the trucks, and they're in charge of essentially owning that whole area and managing whether trucks can come in and so forth. And so they've got features in order to be able to achieve that. Graders, there's a grader system. When a grader is working on a section of road, they have the ability to create a zone where the trucks can't enter. They can also create bypasses. So you can see here, basically this truck is able to divert around this keep out area that this grader has established here while they're doing work. And then like vehicles, which I already mentioned, they supervise, and they're able to refine the boundaries of areas, which we call, they're able to do surveying. And in our world, surveying means essentially driving along the edge of an area and essentially marking borders, just using the onboard system. So they're able to do that, and so, for example, as dumps extend or as areas change, they may drive around and update those boundaries so that the system knows, the extents where the trucks are able to drive. So all of these roles, they all work together, and yeah, I mean, these are sort of the key roles that are required in order to keep this system running well. We also offer, so now I'll get a little bit into, I guess, what comes, what happens when you have a site that's for the first time putting in one of these systems and what they have to go through. We have a pretty extensive training program, and basically we're able to, part of the planning process and implementing one of these systems involves a lot of this training, and then it's ongoing afterwards. So all of the roles in that, in the previous slides that we were talking about, there's a training program associated with them, which includes, it starts with some basically e-learning, virtual scenarios. So we've got simulation, the ability to simulate, and also to play out scenarios virtually and measure their reaction to those scenarios, and then it graduates eventually to in-seat training, and in the end, a certificate of competency. So we work closely with our customers to manage that. They all users of the system are required to have a certificate of competency before they're able to move into live operations. Also we do a lot of work with our customers on performance assurance. What this is sort of a post-deployment performance, like ongoing performance measurement and continuous improvement. And that takes place at several layers or several levels, right? Starting, mine planning and making sure that the processes internally at the mine take into consideration the constraints that we have in the autonomous operation, and that those inputs are fed in the most efficient way possible. Monitoring of basic KPIs and productivity, and making recommendations to our customers. Analyzing that operation. System development is also considered a continuous improvement activity. We basically, one of my jobs as being in product management is to take our customers' feedback and needs and understand them well, and translate those into constant continuous improvements in the system itself by developing new features or improving things, and releasing those on a frequent basis back to the customer. So that's really kind of an area that I'm involved in. And then optimization, looking for ways to further improve operations by reviewing logs and playback of scenarios that have happened at the site, those types of things. Ultimately, our goal, sort of at the bottom here, is getting to best practices and helping our customers maximize their what they get out of the system. And then, of course, there's support. So we also have our own support teams, which we actually have sort of 3 tiers of support. It starts at a local, what we sort of call our tier 1 support people are local. They are either on site or at least in the region. So for example, we have a team in Australia that are with our distributor in Australia, who work directly with the customer, and they deal with the day-to-day issues and help the customer solve problems, kind of in a real-time basis. Then there's a second tier, which are folks who are our AHS support folks in our offices. They're actually both in Japan and Australia, but they're dedicated to customer support more on the corporate side. And then we've got what we call tier 3, which are on the development side. Those are the folks who are actually implementing fixes and working on system improvements and those things. So those 3 tiers work together to provide what we hope is considered a high level of support for our customers to to keep the system running well. And I won't talk in too much detail about this, but we start, in order to implement this system, there's sort of a multi-step process that we go through with our customers. And this has evolved over time. If you go back about, let's say, 10 years, the customers that, we were sort of only working with some major early adopter customers who had, well, I guess one of the prerequisites for us to work with any customer when it comes to an AHS implementation is a solid relationship with Komatsu, and so you see some of that reflected here. We spend a lot of time working with the customer to understand how what value that we're going to be able to provide, and to plan out to make sure that all of the change management and the time-intensive work that needs to go into preparing for this happens, and that there's sufficient dedication to that process. And so there's multiple steps that we've defined essentially through implementation in order to make sure that this is successful. And I think in these slides it talks a little bit about it. So readiness for the AHS system. There's a number of factors across the board which sort of measure how ready a mine is to go down this route. Business factors, so being able to support the system from an organizational standpoint and a structural standpoint too, in terms of the communications infrastructure, for example, those types of things. Compute and IT infrastructure. Then cultural factors. We want to make sure that all of our customers have safety clearly as their #1 priority, because for us that's sort of a no compromise aspect. We don't like, we sort of get uncomfortable when we get customers who are really trying to focus on speed and I don't know, areas which may have a trade-off when it comes to safety. That for us is sort of a non-starter. So that we always make sure that that's a key part of working with any of our customers. Commitment to moving forward to what AHS is going to be. So the relationship with Komatsu, we look at our customer relationship as a long-term partnership, and we want to make sure that that's fostered and achieved, and that we have a long-term plan for this. And then, of course, other factors which geographic location, I suppose, is one. For example, there are parts of the world which are difficult for us to support, and so we've had customers in some regions asking for the system, but we just don't have the right resources in place to be able to support that. Sometimes that for us is a limitation, and we try and be very straightforward with our customers about that. And part of what we do is kind of when we're preparing to offer this system is that we will simulate the environment. So we will do some work to generate a model of the mine, to do a sort of before and after comparison. If you were to put AHS in place, this is how it's going to affect your operation. In certain cases, it's I can honestly say that automation isn't necessarily the right choice. We have run into a couple of cases where we've told potential customers that things are just, the conditions are just not quite right, for you to move forward with this. A lot of times we can work around those things, and we can find ways to mitigate that. And that's our goal here, is to identify those and to be, make sure that there's a lot of transparency there. This is just kind of an example of some of the, we have a sort of a standardized way of checking the, reviewing the, the opportunity and working with our customers to answer a lot of these questions about, creating the simulation and we want to make sure that it's accurate. This is sort of what that output might look like. So how you can see here, time usage, that's a big deal, right? So you've got, might be hard to see, but manual versus AHS, looking at how that operating time, is measured and used, whether there's value there. How it would affect fleet size. So in some cases, you can reduce the number of needed trucks for an equivalent level of productivity. This is looking at that and trying to identify how many trucks you really need for your production goals. And then, shovel truck pairing, those types of things. So these are details that we look at carefully. And as far as a deployment timeline, it sort of looks like this. This you can sort of see this is showing 14 months. There are cases where it's longer than this, and there are cases where we've managed to do it a little bit shorter, but generally this is really what you need. And we have a lot of experience planning these deployments out and work with our customers on everything from preparing the site and planning, training, that type of thing. Typically, it's about 14 months from start to finish, from when we kick off, basically. Yeah, and here, I mean, I talked a little bit about best practices already and change management. you know, we assist our customers with this. We work very closely with them, and part of the deployment plan includes change management and spending a lot of time with them, working on their internal preparation and not just the project itself. So that's really what referring to here. And I believe that is it. So yeah, it looks like my goal was 35 minutes and I'm at 36. So hopefully that that was good. I'd be happy to take any questions, and you guys can still hear me, right?
Any questions? Yeah, Dora.
Thank you for sharing the data and information with us. Actually, I have two questions. First off, you know, there is a problem related to connection between the mining equipment and the monitoring systems in the mines. I mean, radars. And I need to know, can we sync the data for two things? First, if it is a problem, geotechnical problem in the place that the equipment working, because when we reviewing the recorded data with the radar, so we can easily know if equipment working there. And another problem for rescuing in the fatality. For example, we can use this data for evacuation. And another thing, can we rely on the data after the fatality? For example, where is the dump truck, where is the shovel, and if we can understand the truck works to rescue after the burdening under the overburden or not. It is my first question. And my second question is related to the report that you show us. I need to know, can we change the data, for example, for the reconciliation? I need to check if I change the slope of the ramp. What is the cost? What is the benefit? What is the disadvantage? Can I have this report or not? I must calculate it by myself.
Okay. So about the data, so sort of the onboard data and getting it. So yeah, there's a few good sources of data from the truck, and not only the truck, but also I think the central side. So everything that happens as the trucks are driving around is, well, they're sort of really granular sensor data, for example, which is mostly just stored on board the truck. There is a rolling certain number of days that's kept on the truck, including all of the scan data, all of the operating parameters of the machine, things like that. And that data is not, well, we're sort of in a transitory period at the moment. Right now, up until recently, that data is not openly available. It's retrievable, but it's not something that, for example, customers can constantly pull. We are actually changing that. We're moving to, you know, one of the things I suppose I can say here is we, you know, as I said, our system's been around for quite a while, and a lot of the technologies that have been implemented up until recently are, for example, not kind of a different path than has been taken, for example, on the automotive side recently, which is a much younger evolution of technology. So we haven't had the capability to do some of that until recently. And there'll be some changes rolling out shortly, which are going to provide better accessibility to that data. the ability, for example, to download, scan information, stuff like that, and you can use it, you know, however you want. If you want to, you know, analyze what's being scanned and or put it into a database. On the central side, we keep track of, we keep a database essentially of all movement, all equipment movement. We have all of the sort of on a near real-time basis, we get feedback from everything out in the field as to where it is at any given moment and what its status is. And so that can be played back, and you can look at, you know, I mentioned in case of any kind of an incident, we can certainly go back and replay everything that happened at that time. So not just for the autonomous equipment, but all of the manually operated equipment as well, as it was moving around. And so scenario analysis has been kind of a key part of the system for a long time. So hopefully that answers your question. It's sort of an evolving thing, and we're trying to, you know, our customers want to use that data for many different things. And we are working to get to a place where, you know, we simply can provide it, and the customers can work with it however they would like to analyze whatever type of problem they want to. And part of that also is trying to understand operationally what, you know, for example, when you've got trucks being slowed down due to interference that comes from the manually operated vehicles in the area, which are causing them to slow down. You want to be able to analyze those scenarios, get statistics, and create you know, improvement plans for your people so that you maximize productivity. You know, sensor data from the trucks in terms of you know, to try and analyze how rough the road is, to look at you know, to try and determine automatically whether you've got to do maintenance on the road, all of those types of things. And there's lots and lots of potential there, and we're trying to make that more open as time goes on. So does that answer your question?
Yeah, thank you.
Okay.
Jawad?
Thank you, Bill. My question is, like, as a university that we are educating future mine engineers, what kind of skills or different skills that employment of technologies, AHS technologies require, you know, the future mine engineers to be successful in the industry?
Yeah, that's an interesting question. So yeah, and I'm not sure I can answer that in terms of raw skills. I can tell you though, of course, that the you know, students nowadays are going to be very well, I think, positioned to do, you know, to work well in this environment. And there's a couple things that a couple changes that have been brought about by AHS, which you know, folks who are used to virtual environments and understand the working remotely, and you know, so working remotely and working using teleoperation systems and you know, managing things from the office. Those are all sort of methodologies and practices that have come into play here. And that has been harder for the folks who, you know, were in the industry, you know, decades ago to adjust to, compared to younger folks who are really kind of used to that as a fact of life nowadays. All of the technologies that we're incorporating into the system are things that you would be more familiar with nowadays. You know, everything from you know, working with touch screens to using these remote control systems, and understanding how, I think it's important to understand sort of the GPS and the navigational aspects of how these systems work and the constraints that they're under. What to do with point cloud data and what that means, and all of those. A lot of I sort of mentioned automotive earlier. In the automotive industry, there's been a lot of rapid development and really advanced stuff coming out. Those types of things, they're not really a strong, they haven't been incorporated into our technology yet, but it is coming in the short term. It's something that you'll start to see more and more of. So for example, sensor-based navigation. So understanding how, in the automotive industry, they've started to put in place, those systems are independent. They run, a car running autonomously down the road today is sort of self-contained. It has all of the sensors that it needs to drive itself without needing anybody centrally managing it and giving it detailed instructions. That's sort of what the future looks like, and that's what understanding that, I think, is sort of a good, really also a good way to be prepared. So yeah, it's interesting times are definitely ahead. There's a generational changeover which is going to happen. I mean, in terms of the technology, that's going to happen very soon.
Thank you.
Carl?
Yeah, I have just a quick question. I applaud your safety record, and I think it's a fantastic thing. I am kind of curious, though. Back in the old days in MSHA, we had to explain incident reports with accidents and just property damage. Have any AHS vehicles been involved in anything like that?
Yeah, I mean, if you look at, and of course, what I'm talking about, this is public stuff too, right? That you can find. There have been incidences where, things have happened where, one example would be trucks that back too far to the edge of a dump and end up, falling off the back, or inevitably you've got course outs that occur, so trucks slip and they slide off the road. I mean, that happens pretty much at every site. One of the great things about autonomous being around or having an autonomous system is that you don't have the operators in those scenarios, which operators slip in trucks also. And so I mean, yeah, those incidences have occurred. I guess the thing that we're proud of is that it's never, as a consequence of a problem with the system, there's never been anybody hurt, and that's sort of a testament to the fact that there's a very stringent set of rules around the operation of this system which keeps people away whenever the machines are in motion. So as long as our customers are following the rules, and we are very strict about making sure that those rules are followed, and we're very insistent on our customers that we don't allow those exceptions or or changes to those rules, that everybody will remain safe. That's our goal.
Any other question from audience?
Yeah, my question is on the deployment side. How do you guys try to go about the change management that needs to happen in order to be able to deploy the systems? Sometimes you'll have vacuum from managers, and some of the operators might not be happy for whatever reason. And sometimes it might be maybe an older manager who still believes in the old way of doing things and is not fond of the new technology. So how do you go about carrying everybody through?
Yeah, it's yeah, what you're referring to happens on occasion, and there's always some folks who don't understand or just don't like it, especially at the beginning. We usually find that over time those things resolve themselves completely, but you know, we work with customers very closely from the beginning to try and identify those issues early and to address them. And you know, it's we never arrive and start implementing. There's always months, as I was kind of showing in the plan, of planning and working with these teams, and even doing. We start with training before the deployments ever begin, and so we work on. We're very careful about communication and about making sure that you guys can still hear me, right? I heard a click like I got disconnected.
Yeah, we are hearing you.
Okay, sorry. Yeah, so I mean, it's sort of that's not my area, so I can't talk in too much detail, but it's a key part of the process. And yeah, I mean, I can also say we've never had, for example, you know, if folks who are worried about, for example, layoffs and loss of jobs, that hasn't been a factor for us. Usually the jobs, for example, the operator jobs, those are resolved by those folks essentially moving into supervisory positions and managing the system, natural attrition, that type of thing. As you know, we have sort of a shortage of operators in the industry right now, so we're sort of filling that gap. So we haven't had that kind of resistance either.
Bill, we have a question in the chat box. It's about
Okay.
what are the key technical challenges involved in developing and deploying autonomous haulage systems, and how are these being addressed by mining companies and technology providers? And another question, what are the main concerns regarding cybersecurity and autonomous haulage systems in the mining industry? And what measures are in place to ensure the security and integrity of these systems?
Yeah. Well, as far as technical challenges, I think we have, I think the extreme safety mentality that we've got really makes things hard for us in some cases. Like we seem, especially sometimes to our customers, can get frustrated with us because it seems like we're very slow, and we're very, but we are very methodical and very, you know, slow to adopt some technologies intentionally, because we need to make sure that the safety cases are taken care of and that things are adopted in a very stable way. And the need for stability kind of for us is you know, affects our ability to deliver quickly sometimes the changes that we would like to and the improvements that we would like to. And so that for us is kind of an ongoing challenge, which we're always looking for ways to improve, but is kind of difficult. There's a lot of tremendously potential technologies that we would love to incorporate, and you know, on the automotive side, I think the other thing too is the durability. For example, what you can do on the automotive side usually won't survive in a mining environment, and so converting those, you know, those technologies in a way that will last within mining is a big challenge. As far as the question on cybersecurity, yeah, that's for us is a constant concern. There's a couple of ways that we deal with it today. One of course, is we incorporate a conscious concern for cybersecurity issues as we develop, and our systems are, you know, we're working to continually harden those and improve those as time goes on. We also keep them disconnected, so our autonomous haulage system is not connected directly to the internet. There's a number of you know, gateways and you know, hoops that you've got to go through in order to establish any kind of outside connection, and that would be only in very specific cases. So isolation is one thing, hardening is another, and yeah, you know, we focus on that sort of on an ongoing basis.
William, may I ask a question related to this security? Do you have any about security of the GPS signal in a deep mine, in a pit? So do you have any environment about the area you are deploying this system? In any country in the world, any depths of the pit?
Yep.
That's-
Yeah, there's a couple of
Also,
constraints.
one more question. Is there any redundancy that you can actually, by switching a control switch, you can manually drive this fleet in case there is something catastrophically collapsing with the GPS system? Or do you have a local GPS versus you are relying on the visibility of 3 satellites, or do you have a local system on over the overall system?
Yeah, so the GNSS system now is like 5 constellations. It's over the last couple of decades, you know, the systems are more robust because now they take into consideration the European and Russian satellite systems, and now the Chinese system as well. And you know, basically, you've got so many satellites now that at least in some cases, those problems are mitigated. There are still cases where we have issues, like our customers that are in extreme latitudes, either north or south, where most of the satellites are on, you know, low on the horizon. You have problems with deep pits. There's also scintillation problems. So you know, the atmospheric interference due to solar activity, which can cause problems for us. So the way we're dealing with that is there are, you know, as you know, I keep talking about automotive, but especially in automotive space, there's been a lot of sensor-based navigation systems which are evolving. So camera, radar, LiDAR, scanning, navigation systems. Our plan is to incorporate those systems in parallel and to use those essentially as backups when we have problems with GNSS. So I thought there was another question you had. I'm sorry. Oh, you asked me about switching manually. All of the autonomous equipment essentially has a switch where we can flip back to manual mode. So yeah, if there was ever a need to put an operator on a machine, it's just a matter of, and you can do that selectively in certain machines or all of them, whatever you want. That's a pretty easy thing.
Thank you very much.
Bill, thank you so much for your wonderful presentation, and we are really appreciated. Thank you so much.
No worries. Yeah, I appreciate the chance to speak with you.
Thank you.
You're welcome.
We would like to announce the next seminar, actually webinar is next week, and Dr. Kimberly Morrison will talk about the tailing dams. And it's the same time and same link for audience from Zoom, same location for students. Thank you so much.
Thank you.
Bye.